Welcome to this session of rapid prototyping. In this session, we will discuss some applications of rapid prototyping. In previous session, we already have discussed two different applications of rapid prototyping. The first one was application in design, when we talked about different applications in design of rapid prototyping, and the second session was on applications of rapid prototyping in engineering analysis and planning, when we talked about how rapid prototyping can be useful during the engineering analysis and planning phase. Also, subsequently we discussed applications of rapid prototyping in the field of manufacturing. Specifically, when we talk about manufacturing and applications of rapid prototyping, mainly we are focused towards toolings because we make tools from rapid prototyping techniques which will make ultimately manufacturing very faster when we are specifically talking about mass production. Otherwise, when you want to produce very low number of components such as 2 or 3 components, we can use rapid prototyping directly to manufacture those components also. And again, let me remind you that when we are talking about applications of rapid prototyping in the field of toolings, main applications of rapid prototyping in the field of toolings will be in the area of pattern and mold making and die making. We are not using rapid prototyping very widely in the field of cutting tools, but in the field of mold making and pattern making, also in die making. So mostly in formative technologies we are using rapid prototyping for toolings. In this session, we will talk about a term known as reverse engineering and how rapid prototyping can be useful when we do reverse engineering. Now, many of you would have heard this term reverse engineering. What is reverse engineering? Reverse engineering is basically a process when you do not have any design ready with you, but you have a product. So, you produce or reproduce the same product from the product itself without any design data. So, you have an existing component and you want to produce the same component, or you want to do some modification in it, but you do not have any design with you. So what we do, first we identify the component and we make a design from that component, and from that design we make the component again. So this is the process of reverse engineering. But what we are doing, we are using rapid prototyping in the reverse engineering. So when you are using rapid prototyping in the reverse engineering, we can do the design part faster, as well as we can produce the components very fast. But when we are doing this reverse engineering, the first important step is to convert the existing component into a design. So first thing is to generate a surface. That means converting the physical object into a design. So how we can generate the surface? We can use some methods to generate a point cloud, and from this point cloud is basically a point in the 3D space which defines some points on the object, and from this point cloud we can generate our surface, and from that surface we can generate a product with the help of rapid prototyping. Now, how this point cloud will be gathered? So we can use many techniques such as manual probes, which are placed against the object by hand, and we can point that point. We can plot that point in the software in a 3D space with the help of some computer technology. And if you do not want to do this manual process, there are CMM, that is coordinate measuring machines, which basically follows the same process, but CMMs are automatic, and they get filling of the surface, the point with the help of sensors and electronic uh, data. So this is what the point cloud is. There is also another technique such as laser scanning and CT scan or MRI, which also will generate point clouds. Now, while we are generating surfaces, the manual probes, these are the manual probes. When you have to manually move the probes and you have to touch, this is the portion which will be touched to the object, the object you want to regenerate or reproduce. So you touch this uh, say a probe to each point on many points of this object such that you gather most of the surface geometry. So we touch this probe on the object on hundreds and thousands of points, and we get the exact location of those points in 3D space. So this is manual probe to generate point cloud. Once you have all those points, this is what you get. This is what we are talking about. This is an example of point cloud of a torus. So here we are not getting any surface, we are getting hundreds and thousands of points, but they are in the 3D space and they represent the object. Now we can use some software to make this point cloud into solid or into surface, but we will talk about that later. Another technique is CMM, where you use CMM machine, coordinate measuring machine, to generate point cloud. So here this machine will be automatic and the machine will work the same way. You touch the probe to the object. Here is another example of CMM, where you are touching the probe to the object, but you are using some manual control. So this process can be done with manual controls or it can be done automatically entirely. Another technique to generate point cloud is laser scanning. When we scan the object in 3D space with the help of a laser, what will happen is when the laser strikes and it will go back to the receiver, and the time taken from this object to receiver will be measured, and according to that time the entire 3D representation of this object will be achieved. There are also other techniques of laser scanning also, which uses emitter in one place and receiver in other direction, but there are many techniques in short, but this is one of the example. Now another one technology is CT or computed tomography, or the alternative technique is MRI, magnetic resonance imaging. Both of these techniques are mainly used in medical applications, mainly, where you can scan a object according to its density, and from that data you can print a object. So this is an example of MRI image of a pineapple, and this is how this MRI or 3D scanner works. So what we do here is we emit some rays from one direction, X-rays or some magnetic resonance from one direction, and we gather data from other part, and we rotate this entire setup so we can get these different images in all the directions, and from that data we can produce a 3D object. Now once you have point cloud, how to make it to surface and then to solid? So from point cloud we can get STL file directly, or we can get a IGS file which can then be converted into CAD model and which can be converted into a STL file. So once you have this point cloud, the software will convert into a surface or 3D model file, And once you have this 3D model file, you convert it into a STL file, and STL file will then be given to rapid prototyping machine, and you can produce very complex shape, very complex design with very less time without doing the design, measuring of dimension, etc. And you can have the object directly. Now, where this reverse engineering application can be useful, so when you are dealing with some object, some design which are very unique, for example internal organs, tumors in bones or brain, and bone fabrications when needed, so these are very design specific. This will be unique for each person. So you can gather data from MRI, and you can generate point clouds and can easily reverse engineer the organs, or you can reverse engineer the gaps due to the tumors, etc. Or we can use these reverse engineering applications to regenerate the dinosaur fossil. Suppose you get a dinosaur fossil in a rock, and you know that there is a dinosaur fossil, but when you remove the rock and when you get the dinosaur fossil, it will not be in single piece. So how will you be sure that the structure that you have removed from the rock, and when you restore it, it will be exactly same? So you can 3D scan this rock prior to removing it, and you will have a point cloud of the dinosaur fossil structure inside it, and you can 3D print it. So when you remove the bones in the part, you can use the 3D printed model, and you can restore the structure entirely with the help of this 3D printed structure. So these are few of the applications of reverse engineering which will be useful with the help of rapid prototyping. So this will be it for this session. In next session, we will discuss applications of rapid prototyping in the field of medical. So we will discuss medical applications of rapid prototyping. Till then, happy learning.